practice the shape first. Here's our. Okay, go ahead and grab that bad boy. So just. Alright, let's start right down the next one. Talk about how much stuff. Refused and Billy out. We're going to pull those off and make the math easier for us later. Because 50 is a nice number for a number of reasons. Number one, it's exactly the minimum we need to test. Number two, it makes the mathematics you have to do easier in a minute. Now that's not going to matter in general because we have technology eventually. But the mathematics here I want to keep simple. I want to keep it simple. I want to keep the math simple so the theory will come through while we're cranking this thing manually. Yeah, please.
Do you have Genius on your iPhone?
What is Genius?
Well, it's part of the, isn't it, that's what it's called, part of the iTunes thing
I-
where.
It just makes a playlist based on a song.
What you like to.
I made this playlist myself, so it's not making anything
Okay,
for
so
me.
it's basically this playlist, not taking that, your listening style and choosing your shuffle.
I mean, but making the playlist and by overriding it each time,
Okay.
we're trying to get right to the core of the randomizer itself.
I'm just making.
Good.
If it says, oh, you're not happy, let me play you something I know you like.
Oh, I gotcha. And that's dependent on the genre tag too.
Right.
But this, I think we got ourselves some good data as far as testing the randomization of the iPod or iPhone, whatever. You know what? You can totally keep a template handy for this one. This is going to take us a while to work through, just because we're going to crunch the test statistic manually this time. Just so you know, it's going to take a bit of time, because this one is pretty labor intensive to understand. It's a different test statistic than we've ever used before. Because it has to be. And let's talk about why. Let's talk about why before we go any further. So what do you think? First impressions about this? Random enough?
I'd say so.
Say, very quiet. Andrew's like, I say so.
Yeah,
Too much? No?
I think
Oh, yes. Okay.
there's a little bit of clumpiness.
This is clumpiness. Yeah, we got quite a bit of no effects. Nine no effects occurrences. We liked our Iron Maiden today. We loved our Run DMC. Sarah made an interesting comment, and it's almost the exact same thing about a year and a half ago. About 20 songs in, we hadn't heard Pat Benatar's like sexist playlist. It's totally awesome. It was almost the exact same thing happened about a year and a half ago in a 244 class. And that's what's so fun. Do you know that on average how many songs you have to play until you hear every song? At least once?
Probably
It's a fun math problem.
1.5 or 2 times your playlist. Like, what you're looking at?
It's related to how long your playlist is. If you need a number, it's 10 over 10 plus 10 over 9 plus 10 over 8 plus 10 over 7 plus 10 over 6.
Right.
All the way down. So it ends up being, say that again?
10 over 10,
But it's added, not multiplied. So 10 over 10 plus 10 over 9 plus what's a sum, if you will, instead of a multiplication. It ends up being a pretty freaking huge number.
Yeah.
Exactly.
Okay.
It's a finite sum of terms, of 10 terms. And it's based on something called the geometric series, and don't memorize it because it's not, you don't always Google if you need that kind of information. But we were falling in, I believe, right about where we should have been when that, I think Pat was the last one to be heard, but I could be wrong. It might have been Billy Bragg. But they popped in right about the right amount of time. We got our first repeat in just about the right where it should have been, which is pretty cool. So, votes for randomness, yes? Yes, it appears to be about randomness. It's just messy enough. Who says it's a little too clumpy on the top end? Nobody?
I think it's like maybe right on the fence.
Maybe right on the fence. So if we were to test this using a p-value, the p-value might be... If it's right on the fence, what would it be? Right around 5%, right? If it's on the fence, that's cool. Let's see if that... What's funny is when you guys...
5.1 to 4.9.
Good. When you guys did your last exam, I had the exact same gut feeling about my CPR exam, and that's exactly what happened. It was right on the fence about where it should have been. So this is cool. Let's see how our guts correspond to the test that's actually used to do this. Good. So let's ask a question. We'll grab your template. We'll fill the template out halfway, then start crunching the data, and we'll see where we have to go with it. What variable are we testing here, do you think? What variable do you think we're testing? Gut feeling. I hear votes for P. Little p? How come? Please.
How come? Oh, I don't know. I'll just raise my hand.
Oh, raise your hand for which variable?
P.
For P. Oh, for P. Okay, so I think we're agreeing with we're testing a proportion. What proportion are we testing? And let's define randomness numerically. Let's turn this off for a second. So we're testing the variable P. As a matter of fact, how many P's are we testing right now? There's 10 of them. That's what makes this a cool problem. There's actually 10 P. There's P1, P2. Actually, let's just put it this way. P1, P2, P3, ... up to P10. We're testing all 10 of them at the same time. What should they all be equal to? And what would that be numerically? They should all be the same, shouldn't they?
Would that be 5 or because you're doing 50?
No, forget the 50. That's just the number of trials to get. What would P1 be? Let's define it. Let's define what P1 is. Let's define what P1 is.
Oh, 110.
It's 1/10 numerically, but what is it actually standing for in words? The proportion of time that you hear
Song one.
Pat Benatar. What would P2 be? The proportion of time that you hear song 2. Does it matter which song is which?
No.
Not at all,
It
Andrea.
should add up to 1 then, right?
And that's why they're 1/10. That's why you guys figured out this has to be 1/10 or 10%. Because if they're all the same, it has to sum up to 1. If there were 5 songs, it'd be 1/5. If there were 20 songs, it'd be 1/20th. If there were 30 songs, it'd be 1/30th. If there were 1,000 songs, like a lot of playlists have in them, it'd be 1/1000th probability per song. Now, what does that mean? Hold that thought, Kate, just for a minute, What does that mean? What you guys have just done, what you've just done is you've just actually stated your null hypothesis, haven't you?
Yeah.
Inadvertently, by defining the variable, you've stated your hypothesis. Each P is simply the percentage of time you're going to see each song. You're going to see song 1 10% of the time. You're going to see song 2 10% of the time. You're going to see song 3. Say that again.
On average.
On average. Now go with your comment, Kate. You're
I
going
was
to
just
say.
gonna say, so if your playlist happened to be 100 songs long, do you still only need to do it 50 times? Or
No!
your playlist-
Thank you for the segue, sister. I was just about to say. Why did I have us run the playlist 50 times minimally then? Do you? And it's okay if you don't remember this. It's been like 4 or 5 weeks since we even talked about this. What's 1/10 times 50? Sorry. It's 5. Sorry. It's a very, very simple math question, and I think you guys are waiting for something more like.
Well, I didn't know if it was like to the 50th power.
Oh, no. It's 1. Each song is 1/10 occurring. 1/10 times 50 is 5. That was the number you were introduced to weeks ago as the minimum that P times little n has to be in order to kick the test in, so you do enough trials. That's the minimum number of trials you have to do in order for the test to see enough data. So if it were 100, how many would you have to run? 500, right? You'd have to run more. Now the problem is, if you only run 50 trials, you're not going to see every song in a 100-song playlist. If you have 10 songs and you run 50 trials, you're now seeing enough data to get the job done as far as observing the actual occurrences of the data. Is that fair?
Yeah.
Great question. Now just keep that in the back of your mind. There are other more precise tools, but that's a bare minimum. It's that NP equals 5 from way back in the day, from way back in the day. So by running a minimum of 50, because you can see what happened after 20, we hadn't seen one of the artists. Now I'm not seeing one of the artists is in a death sentence for randomization. Wouldn't it be fairly likely we could actually run 50 trials and actually not get a song anywhere? We'll see that in a minute. Yes, the answer to that is yes. You could actually run a perfectly random simulation and never see, for example, Iron Maiden.
Never
God
see
forbid.
Black card.
Yeah, that's what I was thinking.
You guys aren't letting that go, are you?
No.
I love that. That's very happy to hear. So we now have a hypothesis, yes? Now this is in symbols. In words, I'm gonna put the claim. Here's the words for this one. I'm gonna make a Skylar because that request you had for words of weeks ago was great. The iPhone is random enough. There's the words. There's the words for the hypothesis. The null hypothesis. Because we're not testing that. We're testing the claim that people have made about the iPod, which is what?
That's not.
That it's not random enough. And that's your alternative. The iPhone is not random enough. It is not random enough. Renee, what was your question? Go ahead, sister. No? Sure. Okay. So what do you think? How do we test this? Use an old tool, or let's see how we can test using an old tool. Could we test? Oh, Kate, go.
Well, why can't we just have them dependent on one another and just in our, put 1 through 10 and then the amount of times that they occur?
Okay.
And
So
run it that
let
way?
me see if I'm going to keep that track of that over here if it's okay.
That's fine.
So let me swing this over. We got an idea. I'm going to have to turn the computer back on to see the actual occurrences. Pull this down.
Can I ask a question? Please?
Yeah, go ahead.
For the symbols, do we say P1 does not equal P2?
We haven't gotten that far yet. We haven't gotten that far yet. We're working on how to define the opposite of random enough, besides just saying it's not random enough. So we're going to talk about that momentarily, because that's a very, very good question, and a very, very slippery question, potentially. So what you're saying, Kate, is Could somebody give me the numbers? I'm gonna write song, this is not important for the data collection, I'm gonna write the names of the songs, song 1 through 10. So songs 1, 2, 3, 4. This is completely irrelevant, this is just how I put them in the phone. I mean, if we had arranged the songs differently than song, the All Out of Angst, which occurred 9 times, would have occurred way fewer because it would have been a different song. So could somebody just go down the list? I don't care how you label them. Just throw out the numbers. I'm going to call this observed. Observed for observed frequencies. Go ahead, shout them out. 5, 5, 2, 3, 7, 2, 9, 5, 7. Okay, let me just double check, make sure I wrote everything down right. What does that sum up to? 5, 10, 15, 20, 25, 32, 34, 43, 50. Boom. Hey, that's what it's supposed to sum up to, assuming I have everything correctly. So, let me ask you a question. How many times should we have seen? Renee, question, comment?
Shouldn't it equal, like, back to her question, like, if you do the frequency, it should equal 1?
What frequency?
1 times 5, 2 times 5, 8. Never mind.
No, go with that, go with that. Oh, no, careful. This is meaningless over here. This is just to give us a reference point. As a matter of fact, we're going to take it away right now.
Well, that's kind of what I was saying as what you could do in your table.
Yes.
Have just 1 through 10.
Yes.
Our data, and then that be your 5, your frequency 5 is your frequency.
Ah, but that would imply that the 1 through 10 is actually meaningful. Completely
Well,
superfluous.
just that they're paired. It doesn't necessarily mean that
Paired with what? This is a good question.
Their frequency of how
With what frequency?
Well, that song 1, no matter
What it is, Pat Benatar.
Yeah, happened 5 times. However, you could have changed songs 1 to be
Is anybody
song
pissed
5.
about NoFX occurring 9 times? How many times should it have occurred?
It's a 5.
No, it doesn't.
Well, I'm wondering if maybe, like they were saying, if you listen to it longer, maybe it came up more often.
That's totally fine, but the thing is we stopped it at 50, that was our bare minimum. If you play it, what distribution would you expect in a perfectly randomized off to infinity playlist?
1/10.
1/10 of the time, right? So 1/10 of the 50 songs is 5, yes? So how many should we have expected? How many should we have expected for each of the songs? 5 all the way down. That's what we're going to compare it to. That's how we're going to match it. Okay, you got the match idea perfect. It's just we can't match it to their title or to their number because that number's. We could have gone A, B, C, D, E, F, G, H, and then whatever the 10th letter is. Stop
So
it
would
there.
it just be the number of times that they occurred versus the difference of what it
Yes,
should have been?
ma'am.
Okay.
Yes, ma'am. So I want to come back to Deanne's question now. This is obviously going to sum to 50, isn't it? I mean, 10, 5, it's just 50. That's going to be something. Now I want to come back to Deanne's question. Because what are we actually testing here? What are we testing? Yeah, that they're not random enough, but numerically, what are we testing? What are we testing numerically, do you think?
But they're not.
Say that again.
In relation to.
Oh, God, I'm sorry. Let me ask the question a better way. I asked it kind of a crappy way. If we have to put it in terms of the P's, the P1, P2, and P3 and whatnot, what are we testing in that way?
They're different.
That at least one of them is different. That's an excellent point. They don't all have to be different than 1/10. As a matter of fact, some of them are exactly perfect, aren't they? Look, Pat Benatar showed up 5 times. That's what you're supposed to show up 5 times. Song number 2, 5 times. Song number 3, 5 times. Song number 9, 5 times. Those are perfect. The question is there too much deviance somewhere? Are some of the little p values too far away from 1/10? And you can write that any way you want to. It's not important really to write that like specifically. This is different than a single proportion when you go p equals 0.7. Or a double proportion when you go p1 equals p2. It's just at least one of the proportions is different. I mean, there's really no good way.
So are we just, we're going to be looking on it, the couple of 2s or the 9, pull it?
Those are the most extreme, yeah?
Yeah,
So what Kate has just noticed is the 2, are there 2 2s? There are 2 2s and there's a 9. Those are the most extreme deviances, yeah? Those are the most extreme. So if there is an issue, it's most likely with those extremes. Good. Hold that thought. Hold that thought. I want to make sure you see why we're writing this kind of in a sentence as opposed to a full equation, if you will.
Because it would be long if you had
It
to
would
say
be-
this or
oh my
that
God.
or this.
What's 2 to the 10th power? What's 2 to the 10th? It's 1,000. It's about 1,000. It's about 1,000. You would have to write 999 separate statements to talk about the opposite of this. What's the opposite of P1 equals P2 equals P3 equals P4 equals blah 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 P10? It's not that they're all not equal to each other. It's that some of them are not equal. So P1 might be significantly different where the other 9 are fine. P2 might be different where the other 9 are fine. P3 might be different. And you know what? It might be P1 and P2. It might be P1, P2, and P. You see how crappy this is going to get right away?
Yeah.
So what I'm doing is I'm kind of throwing back to 243's projects.
Yeah, I did.
Remember that? The at
Yeah,
least
but-
one? We're trying to use that idea here because that's so much better than writing out 900 plus outcomes. Yeah. Fair? Decent? Excellent questions.
Are we gonna do the 1 minus none?
We don't even have to because the test statistic that's set up is actually extraordinarily
Just go
convenient.
back to 240.
Well, I mean, you typically you did. Now, hopefully you also see why we can't just pair them up. Or we can't just test them one at a time. Like we can't test P1 equals 1/10. Then test P2 equals 1/10. What happens there? Again, confidence in the toilet, right? You're down to below 50% confidence then. So you might say, in a quick step, we'll just raise the confidence. So that way when you do 10 of them, your confidence falls back to 95%. To which you now reply after doing this quiz. Oh, 2 of you did the quiz. If you raise the confidence, which means you lower the chance of a type 1 error, what else do you do? You raise pretty much exponentially the chance of a type 2 error, false negative. Damn it. So what we want to do is have one test all of them at the same time. That'll take care of 95% confidence and maintain that type 2. Let's do it after the break, yes? Let's take our 5. I'm watching the clock and we're over by a couple minutes. Come back and start crunching this. Yes, Kate, you've got it though. The 2 and the 9 are gonna be the ones that are weird.
I'm just curious to see if both the 2s are gonna pull it one way, or if the 9's gonna over.
Or if it's going to bounce, right? Because two down from 5 is what? That's 3 down from 5, right? So 2 of them will be 6 down overall on average. But then there's also 3, which is also
And
down.
there's a 7.
And there's a 7 and a 9. So it almost seems like the downs and ups almost cancel. But the thing is, the way the statistic is created is not perfectly linear like that. You'll see why momentarily. It also throws back to 243. Michael?
When you're doing 50 things in 10 different lists, it has to go.
So that's what I was just.
The linear deviations do, but this test statistic is not linear. That's what I was saying. Yeah, it has to, because you guys proved that in 243.
You could have 50 of song 1 and it would still go to.
Give me
average
3
five.
minutes on that comment, because you're going to see something you've seen before happen right here. And it happened in 243 with Bert and Ernie. And that's exactly what you're talking. Yeah, exactly right. Kate's like, oh my God.
I just
Thinking of Patty.
But that's why I said it's not linear. If it were purely linear, it'd be awesome. But the problem with being purely linear is it's meaningless.